Why, hello, you people from Earth and outer space. It is I, Alexander from the universe. In this episode of Let's Rust, we'll go over various different mathematical operators. You may remember in school how there was math class, whereas you had to use various different symbols in order to change numbers. It was addition, subtraction, division, and multiplication, and in most programming languages, including Rust, there's the same thing. Mathematical operators. The slight difference of there being more than those you might already be used to. Because knowing variable bindings and the different types they can take on is all very well, but there are a lot of times when just having a stationary variable binding like x, where it's set to 8, there are times you want to change this into something else. If we were to run this, we are going to get a very boring outcome. This doesn't really do anything. As a matter of fact, it does nothing. Isn't that sad? I know, it's extremely sad. So what if we wanted to have a program that you have a binding named age, which starts at 8. We're going to print that binding out using a print line. You are of years of age. And provide the print line with the age binding. Run this now, it's going to say you're 8 years of age. But then down here, we want to change age into, say, 9. We want to add 1 year because it's already been a year. You know, the Earth orbits the sun really, really fast. So age is going to be, take on the value as age plus 1. Now this isn't going to work because age is not mutable, so we're going to need to change that into mutable variable binding. So let mut age equals 8. So now this down here is going to be perfectly valid. If we were to evaluate this and run this, it's still going to say you're 8 years of age, but we're not going to get any complaints because we're setting this equal to the same thing, 8 plus 1. We're going to print this out now. Let's just copy this. And it's going to say you're 8 years of age, you are 9 years of age. Isn't that wonderful? But having to type out age 2 times is bound to be rather painful over long periods of time. So rather than typing out age twice, we can use a combination of the equals operator and the plus operator. We can do combination of the equals sign and the plus sign. We can type out plus equals instead. Now the plus equals is going to assign, it's going to use this operator right here, and it's going to add 1 to whatever comes before the plus equals sign. So if we're to run this now, we're going to get the exact same result as the previous run. Now there's not only the addition sign, because that would be really silly. Let's say we were traveling back in time, Earth was orbiting the sun backwards for some reason. So rather than doing plus equals 1, we'll do minus equals 1. And we'll remove 1 value from that of the age binding. And this is all very well, but there are times when the Earth is orbiting the sun so fast that it multiplies the age by 2 every orbit around the sun it does. Rather than doing a minus sign, a simple dash, I'm going to use an asterisk to multiply the value of age by 2. So running this now is going to yield us you're 8 years of age, you're 16 years of age. But of course, if there are times where the sun orbits both forward and backwards in time and multiplies because it's going so fast, there's got to be division, right? And we can use division using a slash. Now we're dividing age by 2. Age divided by equals 2. So whatever value age had, it's going to divide that and assign it using this equal sign here by 2. So age is bound to be 4, right? And it is. It's 4. How beautiful is that? Now what if age was, say, 9, and we try dividing it by 2? Since this age binding right here is an integer, and we're dividing that integer by 2, then isn't that supposed to be 4.5? But an integer cannot take on a value such as 4.5. When we run this, it's going to say you're 9 years of age, you're 4 years of age. Now this is due to something called integer division, whereas the division is able to divide 9 into 2 equal stacks of 4, but then there's one number left that it cannot divide. We've got a single 1. So that would look something like 4, 4, and 1. So the answer of an integer division of a variable binding that's 9 divided by 2 is going to yield us 2 stacks of 4 and 1 as a remainder. So the answer is 4 with 1 as a remainder. Now there are times when we might want to retrieve that remainder. So what if we want to retrieve what remainder we get from dividing age by 2? Then rather than having a slash here for division, we type in a percentage sign. Do age percentage equals 2. When we run this, we're going to get your 9 years of age, your 1 years of age, due to us retrieving the remainder of the age binding. Now if you wanted to, you could just use the boring technique, the really painful one, and type in age percentage 2 as well. You could do that for every single mathematical calculation there is. This will yield the same result, and it would just be really painful. But there are times when you actually might want to do this. Say we have a more complicated calculation that we want to go over. Let's say we have let mut age equals 9, and then we have another binding here that goes by the name of x, which is whatever age is divided by 6 plus 8. Now it's worth to notice that age needs not be mutable. Now all of a sudden it would be really painful for us to type this out on multiple lines of code. If we were to run this now, it's gonna work. And we could even go as far as print that out using print line. X is whatever x is. Like so. It's gonna say x is 9. Now isn't that strange? Look at that. Age divided by 6. Is that 1? As a matter of fact, it is. It is 1. It is 6 stacks of 1 with a 3 as a remainder, which we can prove by doing this. The remainder is 3. And just like in regular mathematics, if you want to specify the order of operations on your own, so rather than having 0, 8, rather than having first calculate this term and then add 8 onto whatever this becomes, you can add brackets like so, parenthesis, regular good old parenthesis. And if we run this now, it's going to say x is 0. That's not so strange now, is it? It does have one big remainder, a remainder that is in fact 9. X is 9. Since 6 plus 8, which is 14, is bigger than the number of age, which means that using integer division, we cannot, for the life of us, put it into equal stacks without actually having a huge remainder. But what if we wanted the result to use decimal points? Now, we can make that happen as well. We were to type in 9.0 here, and then run it. And you're like, what? If we divide it, rather than taking the remainder of it, and then run it, you're gonna be like, what again? Then you're like, 0.0, 0.0, and you run it again. And it works. All the different terms, when dividing and adding numbers inside the same binding, need to correspond to the same type. Otherwise, the calculation is not going to work. Now, there are ways, which we'll discuss in future episodes, whereas you can change one type into another in order for us to do more advanced calculations. Because surely, this is going to be a huge pain if everything needs to be of the same type, right? Why goodbye, people from Earth and outer space. It is I. Oh man. Why goodbye, people from Earth and outer space. Feel free to leave a comment saying something either hilarious or perhaps even a like. Until next time.